Hey, for part A, I want to share with you kind of a newer approach there, a little quicker approach than kind of what we've done in the past. First, when you're going from the f prime to the original f function, we know we're supposed to integrate that, right? So I can integrate f prime, I'm going to get the f of x. Let me kind of show you, let me kind of connect this to like the initial position type of problems. I'm going to start with this one, this f of 5. When I want to find f of 5, you gotta have your starting point, and here's your starting point. They tell us f of -2 is equal to 7. So this is where we're at, like, assume that's like where we're at like t equals -2 seconds, right? That's where we're at, our starting point. And then when you integrate the f prime, what you do is you pick it up where you left off, and then you go to where you wanna go. So this is like an initial position. And then this, when you integrate, because this is your derivative like a velocity. So when you integrate the velocity, it gives you a position. This tells you how far did you go in between -2 and 5. And this tells you where you're at -2. So this is like your initial position. And we start with that because it gave me that. Like if it told me f of 1 was equal to 7, I would have f of 1 right there. And I put a 1 right there. So this is where I'm at, like at t equals -2 seconds. And I pick it up at that same number and then go to where I want to go. So like on this one, when it says f of -6, I start with f of -2 because that's our initial position, and I pick it up where I left off at x equals -2, and then I go to where I want to go. So kind of can keep that in mind. After we do this whole problem, I do have a separate way of work this out. This is kind of how we approach those in some other problems in the past. So you kind of look at that if anyone tried that, but let's kind of finish this one up here. Let's finish this bottom one down here, right? When I do the integral between -2 and 5, you know your number representation of our integral is going to be the area in between -2 and 5. So this area of a semicircle, that's pi times r squared divided by 2. That's pi times 2 squared divided by 2, which is 2 pi for that area. But since that's below the x-axis, you got to stick a negative in front. So that's going to be -2 pi for that part. And then this is just a triangle. So 1/2 times the base times the height, that's 1/2 times 3 times 2. And then so the 2's are going to cancel. You're just going to get a 3 for that. And then again, they gave us that that was equal to 7. So 7 plus the 3 minus 2 pi, got a 10 minus 2 pi for that. That's the exact answer. No calculator on this one. And then the little tricky part, when you did that -6, when you do the integral between -2 and 6, remember if it's not least the greatest, you got to switch them, make it left to right least the greatest there. So when you switch the numbers, go from -6 to -2, then you got to switch that symbol to make that a negative right there. And then you're going to do the area between -6 and -2. And so that's this guy right here. That's just going to be 1/2 times the base, which is 4, times the height, which is 2. 2's cancel out, you're going to get a 4. So 7 minus 4, that's equivalent to 3. Letter B says, where is f increasing? That's an easy function. We know f is increasing where the f prime is positive. And if we give you the f prime graph and say, where is that graph positive? That means where is that graph have positive y values? Where is that graph above the x-axis? That's in between -6 and -2. And that's in between 2 and 5. And we always use the open intervals for increasing, decreasing functions right there. So as long as you have your answer, and then it says justify your answer, you got to mention the f prime is positive. That's me. So I usually have this since f prime is positive right there. Now, when you find an absolute, remember, I'm going to do absolute extrema. You do a 3.1 absolute extrema problem where you do a normal XY chart and you got to check the endpoints of that interval right away and any critical numbers. Now, critical numbers is if I have a function, I set that derivative equal to 0, but that don't have a function, but I know my derivative is equal to 0 at those two numbers right there, -2 and a +2. Now, you could check both of those in your chart if you want to, but let's use our brains here a little bit. It tells us to find an absolute min, and I'm just going to check the x equals 2 because notice at x equals 2, our derivative goes from below to above the x-axis, which means our derivative goes from negative to positive, which means that x equals 2, that's a relative min on that original f graph because my derivative goes from negative to positives. Now, if that's a relative min, it also has a chance to be an absolute min, but it also might be at the endpoints. That's why we got to check all 3. This one, I didn't bother to check x equals -2 because here, my derivative graph goes from above to below the x-axis, which means my derivative goes from plus to minus, positive to negative, which means that's going to be a relative max on the original function. So if the direction said find the absolute maximum, I would definitely be checking that -2 on my chart. You could check the -2 on the chart, just it's not going to give you the lowest y value. It's not going to hurt you to check that. It's just going to be a little bit more of your time. And then from the -6 and the 5, we already knew that this is going to be 3 in the 10 minus 2 pi. So that was kind of nice of them that they already gave us stuff that we already figured out. And then when you want to figure out the 2, that's doing the same thing that we did in part A. So f of 2 is what I'm trying to calculate. That's going to be f of negative 2. I'm going to do my starting point, and I'm going to pick it up where I left off, and then go to that 2 where I want to go to. And that's in between negative 2 and 2. That's just the area of that semicircle, which we already said was a 2 pi for the area. But since it was below the x-axis, it was negative 2 pi. And so you get 7 minus 2 pi. And as you compare those y values, just approximate. Pi is about 3.14, right? So this is like 7 minus 6. That's like 10 minus 6. This is the smallest y value. It's going to be closer to 1. That's going to be closer to 4. That's 3. So this is your smallest y value. They got to give us something that we can tell because it's on the no calculator part of the test right there. But remember, if they say, where does the max or min occur at? That's the x value. If they say, what's the value of the max or min, or what is the max or min, just find it. You got to give me the y value. Give me what that lowest y value is. And then the last part, really, really simple, okay? It says the second derivative at negative 5. The second derivative, to go from the first derivative to the second derivative, we know that's a derivative. We know derivative is slope. So that's just find the slope of that line segment at that x equals negative 5. So I just wrote down the points and did my basic slope formula. Boom, there's a slope, all right? And that's your derivative. And then when you do the derivative at 3, notice at 3 you got a corner point. Remember, functions are not differentiable at the corner points because of the multiple tangent lines. So I put f double prime of 3 does not exist because of the multiple tangent lines that we're used to. And then going back to letter A, we're done with this problem, but going back to letter A, just something that we've done before. If you wanted to do it this way, you can. If you wanted to find f of negative 6, well, I'll just show you one of them, all right? I'll show you both of them. You can kind of pause that and get the answer down, but I'll just kind of show you one of them. If I wanted to find f of 5, I know I would need to integrate f prime. So I'm going to integrate f prime of x. I would choose the negative 2 since it gave me that. And then I would choose the 5 since that's what we were trying to go. So when we integrate f prime, we get the f of x. And we can plug in the 5, plug in the negative 2. They told us the negative 2 was a negative 7. F of 5 would carry down. But then what you need to do is get a number for that integral right there. And that integral right there is the area between the curve and the x-axis, which we already talked about at the beginning of the video. That was like that negative 2 pi plus 3. And then you just solve that equation for the f of 5. So you move the 7 over, and then you get that the same way. So that'll certainly work. But I think if you kind of force your brain to kind of go through this, I kind of started to like that better. It's a little bit quicker and just a little bit nicer for us there. Waffle fries.